Alright everyone, today we're going to learn the inverse trigonometry function. Very important concept. We are going to learn this again later in year 12, and so we need to know how to do this one properly in year 12. Alright, so last lesson we'll talk about inverse function. Now we are going to shift from inverse function to inverse trigonometry function. So more specifically about the trigonometry function here. Alright, so this lesson is going to be focused on the domain and range of the inverse trigonometry function, not really the focus of the curve sketching. All right, next lesson I will show you how to do the curve sketching properly. All right, but we start with sine inverse. Okay, so we'll start with the original function, sine function first. All right, so the original function is y equals to sine x. Now, if I want to find the inverse of that function here, then the first step what we need to do is to change y to x, and then change x to y. So like what we did before. All right, so once we finish that, okay, we are going to make y as a subject. So therefore, we're going to get y is equal to sine inverse x. Right, so that's how we write sine inverse x. There's another way we can write sine inverse x. It's also called arc, A-R-C, sine x. So you do need to know both notations, whether it's either arc sine x or inverse sine x, where you have a power of -1. But you need to again remember that sine inverse x is not equal to sine x to the power of -1. They're not equal to each other. This on the left hand side is the inverse sine function, and the one on the right hand side is just the reciprocal of the sine function. So it's 1 over sine x. They're totally different stuff. Okay, so make sure that you understand these. Okay, now let's look at the domain and range. Sine function from the previous lesson, you know sine function is not a one-to-one function. Sine x is a periodic function here, and it is a many-to-one function there. So therefore, it's not, if we don't restrict the domain, you're not going to get an inverse sine function. It is going to be a relation. So we need to know how to restrict the domain so we can get an inverse sine function. All right, so before we do that, what we're going to do is to sketch the sine x function first. Okay, all right, so from my previous lesson, I've already told you the way I sketch the sine x functions is you find the periods. In this case here, the period is equal to 2 pi, so our label here is 2 pi. Usually 2 pi means like 6 centimeters, so you can draw a nice and scaled diagram, and let's label here as -2 pi. All right, so you halve it, and you halve it again. So this time I'm just going to do this one a bit quickly. All right, and then when you finish that, what you do is you look at the period, and you look at the amplitude. So the amplitude for this question here is 1 and -1. All right, so that's pretty easy to do. 1 and -1. So just put a -1 here. Okay, all right. And the line for the boundaries. But again, you don't really need to do that. Okay, so I'm just going to draw the sine x function. Sine function start from 0. Let me just use a different color. Start from 0, and it goes up first to that point, and go down, and then keep going downwards, and then coming back to 2 pi. All right, so this is the function on the right-hand side. We can complete this entire function, all right, on the left-hand side. Okay, all right. So that becomes the sine x function here. Now, if you look at this diagram here, clearly this is not a one-to-one function. It is a many-to-one function. If you draw, if you try to draw a horizontal line, you will see that it's going to touch, the graph at multiple points. And just make sure, remember for this graph here, y equals to sine x. What I did is I just sketched from -2 pi to +2 pi. Okay, but what we need to do is we need to restrict the domain of this function. All right, so we can find the inverse of the function there. So how do we restrict the domain? We need to basically what we need to do is we need to find a part of the graph here where when you draw a horizontal line, it's only going to touch the graph at one point, one single point, all right? Not more than 1 point. Okay, so the point, the curve I'm going to select is going to be starting from negative pi on 2 to positive pi on 2, that portion here. All right, if we just restrict the domain of this sine x function, all right, from negative to pi on 2 to positive pi on 2, then this part of the curve becomes a one-to-one function. So therefore, if I want to find the inverse of that function there, it is going to be a function as well. Okay, so let's write down the restriction of that y equals to sine x function. All right, so let's do it here. So I think it's better to do it here. All right, so for the original function, y equals to sine x, the domain of this original function is between negative pi on 2 to positive pi on 2. All right, so the range of this one is pretty easy. As you can see, the function is oscillating between 1 and negative 1, so it's between 1 and negative 1. Okay, so that's really easy. That's just the domain and range of the original function. Maybe I'll just use a different color, just easier for everyone to see. Oops. Original function, y equals to sine x. All right, so that's better. Now, that means once we restrict the domain, now we can find the inverse function, all right? And then we are going to have the inverse function, and it's called the inverse sine x. And also, you know that the domain of the original function becomes the range of the inverse function, okay? All right, so how do we sketch it? I will show you the proper sketch next lesson. And but today I'm just going to provide you some overview about how to do a proper, a rough sketch about sine inverse x. But the detail about how to sketch it will be presented in the next lesson. Okay, so how do we sketch it? So the first thing to sketch the sine inverse function, or in order for you to sketch the inverse trigonometry function, the very important thing is find the domain and the range. All right, you always find the domain and range of the inverse function before you sketch it. I couldn't, sketch the inverse function without finding the domain and range first. So if you just give me any inverse function, all right, like an inverse trig function, and you ask me to sketch it straight away, I can't do it, all right? I need to have the, domain and range written down on a piece of paper so I can sketch it properly. All right, in the next lesson, I will show you why this works. Okay, so let's just write an inverse function y equals to sine inverse x. Okay, now what is the domain and the range? This time the domain is going to be between 1 and negative 1. And the range is between negative pi on 2 and a positive pi on 2. All right, now as you can see, I've got a domain, I've got a range, I can sketch my inverse function here. All right, so let's do that. So draw a horizontal axis, draw a vertical axis. All right, once you finish that, obviously, again, this is very similar when you sketch the trigonometry function. I want a scaled diagram. All right, you'll find why the scaled diagram is so useful later when you're solving questions there. So now the first step, basically, you want to create a box. Okay, a box. So you need to use the domain and range to create a box. So it's like this, create a box. With that box, you can sketch the inverse function really easily, okay? So this is the key, create a box. So how do I create a box? Well, use the domain and range. The domain is between 1 and negative 1. All right, so what you do is you measure like 1 centimeter, or if you find 1 centimeter is just a bit too small, that you can increase to 2 centimeters, just double the size, okay? So let's just say, for example, this is my 2 centimeter as 1 unit. Okay, again, as I said, if you find 1 centimeter is too small, change that to 2 centimeters, to treat 2 centimeters or 2 grids as 1 unit. But again, it's up to you, all right? But domain is between negative 1 and 1. All right, once we finish that, then the range, we'll look at the range. The range is between negative pi on 2 to pi on 2. Pi on 2, pi divided by 2 is roughly equals to 1.5, because if we treat pi is 3 units, and 3 divided by 2 is 1.5. So if previously you used 1 centimeter as 1 unit, then you can use 1.5 centimeter as pi on 2. But because I use like 2 centimeters as 1 unit, then in that case you can use 3 centimeters as pi on 2. I hope that makes sense to everyone, okay? All right, so let's just say here is pi on 2, and that's negative pi on 2. Obviously, I didn't do the measurement, all right? But when you do the proper diagram, it's better to draw it in the scale diagram. Okay, so once I have all of this, what I can do is now use your ruler. Just draw a dollar line. All right, they're not asymptotes, all right? They're just a dollar line to give you the boundaries or give you the points that you know where to start the graph. Once you have this little box here, it is so easy to sketch the inverse function of inverse sine function. You just need to remember the inverse sine function starts from the top right corner, always starts from the top right corner. So once you have that box, you go to the top right corner, and that's the starting point. And then I will pass the center or the origin, and I will go to the bottom left corner, which is here. All right, and then to sketch that, it is going to be like this. So firstly, on the right hand side, it is going to be concave upwards, and on the left hand side, it's going to be concave downwards. So all the inverse sine function will look like this. All of them, all right, will look like this. The only difference will be just the domain and range of different equation will be different. And that's the reason why I asked you to find the domain and the range first before you sketch any inverse trigonometric function. That's how you do it. But again, in the future lessons, in the next lesson, I will teach you how to sketch a different one. Like for example, if we have y equals to sine inverse 2x, how do we sketch it? How do we sketch y equals to half sine inverse 3x? These kinds of question, all right? But right now, all you need to remember this lesson is the domain and the range of the sine inverse, cos inverse, and tangent inverse. All right, so this is just this is all you need to remember for the sine inverse, all right? And as you can see here, for this sine inverse function, if you just pay attention to this diagram, it is always increasing. And then it is also in the 1-1 function. So it passed the horizontal line test and also passed the vertical line test. It is a 1-1 function. It is always increasing. Okay, now let's move on to the cosine inverse. Okay, so the cosine inverse, we're going to do the same thing. The original function is y equals to cosine x, and it is just going to be cos inverse x and arc cos x. So going to be the same thing. All right, so in that case, I'm not going to show you the working out how to obtain the cosine inverse function because it is just going to be the same idea from the previous calculation there, okay? So you just change y to x, change x to y. There's no much difference. All right, let's start. All right. Okay, so for, how about, okay, that's better. So here, this is y equals to sine x, and y equals to sine inverse x. Let's just put it here, so it's just a bit easier for everyone to see. All right, so the next one I'm going to do is y equals to cos x and y equals to cos inverse x. Okay, all right. And y equals to cos inverse x. All right. So let's start to do the sketch of y equals to cosine x. It's just going to be the same as the sine x function, all right? Very, very similar. And let's sketch that first. Okay, all right. And I'm just going to do a quick sketch. Same thing, it's 2 pi, from 2 pi to negative 2 pi. All right, so you half it, that becomes pi, that becomes negative pi, and keep doing it. All right, I'm just going to quickly do that. All right, it's oscillating between 1 and negative 1. So So I'm just going to do the dotted line. Now remember, when you sketch this function, again, probably it's better to sketch it properly using the correct scale. Okay, all right, so cosine function starts from 0, 1, that point. And it goes down first, coming down to the pi, and comes back to 2 pi. Same with this side, goes down first, and go up again. All right, okay, so this is a cosine function. Now, have a look at this cosine function. If I want to find the inverse of the cosine x, right? The problem with that is I'm not going to choose from negative 2 pi to 2 pi this time. Because if you choose from negative 2 pi to 2 pi, all right, let's just choose from negative 2 pi to 2 pi. As you can see, if you choose this part, what do you get? You get it's a function, but it's not a one-to-one function. All right, if you draw a horizontal line, it is going to touch, the horizontal line is going to touch this part, at 2 points. So, no. That's not something I want to choose this time. So you're going to choose a different, part of the curve. Right, this time, the part of the curve that you're going to choose, all right, is this part, from 0 to pi. All right, excuse me, from 0 to pi. All right, so if you look at this part of the curve, it is one function. All right, horizontal line test pass. You can draw a horizontal line and only touch on 1 point. All right, so that is going to be the domain I'm going to restrict for finding the inverse function there. Okay. All right, so let's just write this one down. The original function y equals to cos x. The domain of this original function will be restricted as 0 to x to 2 to pi. So from 0 to pi. All right, and the range is from -1 to 1. So the same thing. The range is still the same. All right, so that means that once you know that, all right, we can find the domain and range of the inverse function. So inverse function y equals cosine inverse x. The domain is going to be from -1 to 1. That's the same as the inverse sine x. And this time the range is going to be from 0 to pi. All right, okay. So as you can see, it's different to the previous one. All right, the domain is the same, however, the range is different. Okay, all right, let's sketch this. Use the domain and range. And previously, I remember I told you, I can't sketch this inverse trig function without knowing the domain and range. Now I know, so I can start to do the sketch. I need to create a box again. All right, it's all about a box. I need to create a box again. All right, this time, let me just remove that first. All right. The reason for that, it's the range is between 0 and pi, so I just want to draw the horizontal axis down here. So I have more space up there. Okay, all right, so that's x, that's y. Again, 1, -1. The range is from 0 to pi, okay, pi. The way you do it, make sure you actually do it in the correct scale. Once you finish that, you need to draw boxes, remember? All right, now if you look at that box, it is slightly different to the previous one. All right, the previous one, this box is divided into 1, 2, 3, 4 quadrants. But this time I only have like 2. What I need to do for the cosine inverse is you are going to find the midpoint between the 0 and pi, which is pi on 2. And once you finish that, you're going to complete that diagram to have 4 quadrants there, always. Okay. So what happens if this it's not equal to pi? In the later exercise, that number can be changed. What do we do there? Well, if it's not equal to pi, then it doesn't matter. It doesn't matter what the number is, right? What you do is, if it's equal to 3 pi, then you just halve the 3 pi. If that's equal to 5 pi, you halve the 5 pi. If it's equal to half pi already, then you just halve it again. It becomes pi on 4. Okay. All right, how do we sketch that? So how do we sketch the cos inverse? if you look at sine inverse, I told you it's starting from the top right corner. The cos inverse starts from the top left corner, okay? So just the opposites. It starts from this point. And then goes to the midpoint here, all right? And then go down to the points there, all right, to the bottom right-hand side. All right, and then it's still concave up first. It's always concave up first, and then concave downwards. That's how you sketch the cos inverse function. And it's always going to look like this, as long as you have the correct scale and be able to determine the range and domain properly, then it's always look like this. Okay, so this is the cosine inverse. Now again, at this stage, you don't really need to know how to sketch the harder trigonometry function, inverse trigonometry functions here. But you do need to remember what is the domain and range for both sine inverse, cos and cos inverse, and later for the tangent inverse, because you need to use that to do some interesting questions. Okay, all right, so that's the end of the cosine inverse. All right, now we've got one more to do, which is the tangent inverse, so we can start to do some calculation question. All right, as usual, I'm just going to write here 10x and y equals to 10 inverse x. All right, I'm just going to start with sketching tangent x first. And again, I'm just going to do a quick sketch. The period is equal to pi this time, and then if you halve it, the first time and when you halve it, it becomes the asymptote. All right, so the graph goes this way, and then we have another asymptote at that point. It's actually pretty easy. For the tangent inverse, it's really easy. You will know the reason why in a minute. All right, so this is the tangent inverse, starting from negative pi to pi. Now, of course, I can extend horizontally to sketch more, all right, but you don't have to. If you look at this graph here, again, this is not one-to-one function, so we need to restrict. Now, we need to restrict the domain of 10x so we can have inverse 10x. That restriction is really easy this time. If you just look at the curve that's right in the middle, that is a one-to-one function. Right? That is a one-to-one function. So what does that mean is, what we have to do is for the original function, y equals to 10x, the domain is now going to be negative pi on 2 to positive pi on 2. All right, now have you noticed that this time x is not equal to negative pi on 2 and pi on 2, not like the previous one, which I can show you here. X is actually equal to negative pi on 2 to pi on 2, but this time, all right, it's not equal to. All right, the reason for that is because the tangent x has an asymptote at x equals to pi on 2 and x equals to negative pi on 2, which is 90 degrees. All right, so if you do 1090, it's undefined. All right, what about the range? Very interesting. Range, all real values. So it's all real value of y. So you can choose y to be any number. All right, there is no restriction for the y. Okay, so that means for the inverse function. So for the inverse function, y equals to 10 inverse x. The domain of this function here will be the range of the previous original function, and in that case will be all real value of x. And then the range is between pi on 2 to pi on 2, to negative pi on 2, sorry. So negative pi on 2 to pi on 2. Very interesting to see. Again, there's no equal sign, so remember there's no equal sign here. All right, let's sketch the inverse. All right, so the domain is all real x, so you don't have to worry about the domain, but the range is between pi on 2, pi on 2 to negative pi on 2. And then it's actually an asymptote because it's not equal to these values there. Oops. Oh, okay, that's why. Let me just rewrite this. Pi on 2 and negative pi on 2. And this time is actually this time they are the asymptote, the horizontal asymptote. Okay, all right, and then the tangent inverse graph starts from 0. It goes approaching to the asymptote like this way, concave downwards, and then concave upwards and approaching to the asymptote on the other side. That's how you sketch the tan inverse x. All right, super easy, very simple, as long as you can determine the range of this tan inverse function, and that's it. So this is the easy one. All right, later I'll show you how to do the complicated one where x can be changed, where you have a coefficient in the front, or if you shift the function up and down, to the left, to the right. Okay, how do we do this? All right, now finally we can do some calculation questions. Everything you're learning right now is just to prepare us to do some interesting simple calculation. Yes, it is pretty simple. All right, once you know the domain and range of the inverse tangent, inverse cosine, inverse sine, but it will be hard if you don't know what to do later on. All right, okay. So let me just write down a summary here. So we have, how about I just create another page and I'll write a summary so we can use that summary to do the question. Okay, so I'm just going to write down the domain and range for all three inverse trig functions. And we're going to use this information to do the later questions there, okay? So very important. All right, the domain. So the domain of sine inverse function, I hope you still remember, it's between -1 and 1. For the cosine inverse function, is also -1 and 1. All right, how about, I'm just going to use different color, just a bit easier. That looks pretty good. All right, so it's -1 to 1. And for the tangent, inverse x, the domain is still, the domain, oops. I just did that, okay, it's all real value of x. Okay, all right. Now, what about the range? The range of sine x is y is between -pi on 2 to pi on 2. For cosine x, all right, cosine inverse x is between 0 and pi. And for the tangent inverse x, it is between -pi on 2 and to +pi on 2, but there's no equal sign. All right, so this is just the summary. Now, we're going to use this summary here to do some example questions. All right, so in example 1, you'll probably see what kind of question is related to this. Example 1, it would be like, find cos inverse minus half. All right, how do we do this? How do we do this question? Listen, calculator is not going to help you, so don't use a calculator for a question like this one here. All right, especially for questions that if they ask you to show working out. Yes, you can use a calculator to check, but if they ask you to show working out, you do need to know how to do it properly. Okay, so how do we do this? First step, you're going to let A or alpha, an angle, doesn't matter, theta, doesn't matter. Let alpha equals to cos inverse -half. Because remember, cos inverse, sine inverse, and tan inverse, they represent an angle. Do you remember this? Like when you have sine x equals to, √3/2, and x is equal to sine inverse √3/2, and that gives you an angle like 60 degrees, right? That is an angle. So sine inverse, cos inverse, and tan inverse represent an angle. All right, so therefore I can let alpha equal to cos inverse. And once I finish that, what you can do then is you can rearrange it. It becomes cosine alpha is equal to -half. Okay, cosine alpha is equal to -half. Then you need to determine, this is really important, you need to know, all right, and you need to be able to determine where is the angle, all right, where is the location of the angle, using the information that we did before. Okay, using the information we did before. So I'm just going to create a quadrant here, and I'll show you how to do this one properly. All right, so if we look at that, cos inverse, and then if you look at the range is actually between 0 and pi, all right, 0 and pi. So that tells you that alpha is actually between 0 and pi. Now, where is 0? 0 is here, that's 0 degree. Where's pi? 180 is here. So 0 and pi is in the first and second quadrant. First and second quadrant. Now, how do I know which quadrant the angle lies, right? How do I really know which quadrant the angle lies? Well, the quadrant is in the second quadrant, but how do I know? Well, you know that by looking at the value here. Cosine alpha is negative. Cosine is negative in which quadrant? All right, which quadrant? Cosine is negative in the second and the third quadrant. So then, by combining these two pieces of information together, you now know, right, the angle is in the second quadrant. Okay, so this is how you know it. So you're going to use two pieces of information to finalize, to solve this puzzle here. Use the information from the domain and the range of the inverse trigonometry function, and use the information that you know our station to central. Cosine is negative in the second and the third quadrant. So combining these two pieces of information, that you can see the answer is, alpha is in the second quadrant. So alpha is in the second quadrant. Once you know alpha is in the second quadrant, then the work is really easy to do now. Well, cosine alpha. What is cosine alpha equals to half equal? All right. If cosine alpha equals to half, what's alpha equals to? Well, that's 60 degrees, right? Or this time, pi on 3. So therefore, the related angle, all right, in the second quadrant is going to be 180 minus 60 degrees, or you're using pi minus pi on 3. So the related angle is pi on 3, which is 60 degrees. However, it's in the second quadrant, so you're going to use pi minus pi on 3, and that gives you 2 pi on 3. Remember, second quadrant is always pi minus the angle, and pi on 3 is the related angle, so that's how you get to this answer. All right, so that's the first question, and let's do more. Next one, tangent inverse minus 1. All right, so let's just repeat the same process. Let alpha equals to tangent inverse minus 1. So tangent alpha is equal to minus 1. And then let's create a quadrant to decide which region, okay, which, part, or what is, where is the location of the alpha. So let's have a look at what's tangent inverse and what is the range. Tangent inverse, the range is actually between negative pi on 2 to positive pi on 2. All right, so that tells you the alpha is between negative pi on 2 and a positive pi on 2. All right, negative pi on 2, positive pi on 2, which quadrant? That's negative pi on 2. And here's positive pi on 2. And the angle is actually the first and the fourth quadrants. All right. Now, again, let's have a look. First quadrant, cosine tangent is going to be positive, but however, tangent alpha is negative 1. Negative. Tangent is negative in the second quadrant and the fourth quadrant. So then, combining these two pieces of information, you know tangent is negative in the fourth quadrant, and the alpha is in the fourth quadrant. All right, once you know alpha is in the fourth quadrant, all we need to do is solve the question very easily. The related angle is pi on 4, because that's how you get tangent, equals to 1, right? But this is negative 1. So related angle is pi on 4. Then, if we need to just draw a line like this, here's the angle pi on 4. How do we get that angle there? Well, alpha is equal to negative pi on 4. That's all. All right, because going from this direction here is negative angle. Going that direction there, or anti-clockwise direction, you are going to have a positive pi on 4. So this time it's negative pi on 4. All right? Okay. All right, so if you know how to do this one, then we can move on to some tricky and harder question this time. All right, let's do the next one. The next question I'd like to do is tangent, bracket, sine inverse negative 1 on 5. All right, now this is a bit crazy. You have two trig ratios sort of combined together. All right, how do we solve these? First step, let alpha equals to sine inverse negative 1 on 5. Always do that first. And then sine alpha is equal to minus 1 on 5. Okay? And then quotient diagram, yes. And then what you need to do is decide which, where is the location of angle alpha. So let's go back again. Go back to the sine x. The range is between negative pi on 2 to positive pi on 2. So alpha is between negative pi on 2 and a positive pi on 2. So it's the first and the fourth quadrant. But this is not enough, all right? We need to have more information. Well, this is negative 1 on 5, so sine is negative in the fourth quadrant. All right, so that tells you it's the fourth quadrant angle. Alpha is in the fourth quadrant. Okay, alpha is in the fourth quadrant. All right, so once you know that, all right, this is a very good foundation, okay? Once you know that, we need to now go back to the question. Seems we let this one equals to alpha, so we can now solve the question. 10 bracket sine inverse becomes 10 alpha. All right, remember, alpha is equal to everything here, so that becomes tangent alpha. Now, how do we know what's tangent alpha? We need to create a right angle triangle again. Okay, and we call this is alpha, and then forget about the negative. We use this information, and we use SOHCAHTOA to work out what is the distance of each side. So opposite is 1, hypotenuse is 5. And then here is going to be 25 minus 1, and then that becomes square root of 24. Okay, all right, square root of 24. All right, now, to solve tangent alpha, you just need to look at a triangle. Tangent is 1 over 24, right? Square root of 24. Opposite over hypotenuse. Opposite over adjacent. But because it's in the fourth quadrant, so your final answer will be negative 1 over square root of 24. Okay, and of course you can simplify square root of 24, and the answer becomes root 6 over 12 after you rationalize the denominator and square root it properly. That becomes the answer. All right, so as you can see, so many steps involved just to solve a question like that. So many steps here. Okay, you need to decide which quadrant the angle outlines, and you need to use a right angle triangle, to use Pythagoras. Everything's connecting together now. All right, I do want to do one more to show you to do one more question, so you will understand a bit more how to do it. Okay, so the exercise you will see, that's going to be a bit harder, all right, for you to do if you do if you're the first time to do this type of question. All right, so this one, I'm just going to start to solve it. First step, let alpha equals to cos inverse 4 over 5. Cos alpha equals to 4 over 5. Quadrant diagram. The range of cos inverse, okay, the range of cos inverse, go back to the range of cos inverse. It's from 0 to pi, so that's something you have to memorize, okay? You need to memorize the domain and range of inverse trig function. So it's between 0 and pi. 0 and pi, so it's this quadrant and the first quadrant. Now, let's have a look. That's a positive number. So that means it must be in the first quadrant for cosine angle. So alpha is in the first quadrant. Great. First quadrant angle is always very easy to work out, all right? To work out the answer. Because it's always going to be a positive for all the trig functions there, okay? All right, so what do we do now? Do you remember we need to substitute this one back? Like we put this alpha back so we can solve the question. So therefore, sine alpha is equal to... All right, and we still need one more thing. All right, we need to draw a right angle triangle. We need to call that alpha and try to use this information to put in, the distance of the sides in a right angle triangle. That becomes 4 and 5. Oh, that's a perfect Pythagorean example here. Okay, finally, we've got everything we need. Now, to solve sine alpha, that's here alpha here. Sokotowa, sine is opposite over hypotenuse. So the answer, 3 over 5. And then alpha is in the first quadrant. So it is positive. Great. That's how we do it. Yes, it takes a long time. It takes a huge amount of time just to solve a question, but you will get better. The more question you do, you will get much better. When doing it. Okay, I still remember when I first learning this. When I was a student, I get so confused and I would make so many mistakes because I just forget about determining the quadrant of angle alpha. So I always get mixed up with positive or negative answers. Until I have done so many questions and then I get used to the question and then I know how to do it. All right. Thank you everyone, and I hope you enjoyed this lesson. It's a long lesson here and it is hard. Let me know if you have any questions. I will probably create another video about how to solve some hard questions there, but let's see. All right, okay, thank you.